Hello everyone, this is my geology project. My topic is what is happening to the groundwater in the Southwest. So the main topics I'm going to be going over is what is happening. So obviously I'm going to be going over the water supplies, and I'm going to be going over risks that threaten the water supplies. I'm going to be going over areas that will be affected. I'm going to be going over solutions, and I'm going to be going over what you can do. Solutions and what you can do are going to be different because the solution is going to be more large scale, while what you can do is going to be more individual. And what happens if changes are not made? It's mainly going to be if we keep on going along the same path what we're going right now. So, aquifers and water supplies, they're in decline. According to an article from Scott Jesko, nearly all streams and aquifers which are connected are in decline. At least in the southwest, which is this area. This little map, it shows the streams and aquifers that are in decline. There's only one in California, other than that one I didn't notice until now, that are not in decline, and it's mainly because it's a more arid area. But all the ones here are in decline. The ones in Colorado are in decline. Most of these are in decline, except for in this area, which is a lot more humid. So the areas usually have less problems with keeping their aquifers recharged. So the risk and the reasons why. So I'm going to be going over overdrawing from the Colorado River and aquifers. I'm going to be going over contamination, so nitrogen-based fertilizers, obviously contaminants. I'm going to go over cattle and crops, which are really big causes for the decline, and then I'm going to be going over aquifers unable to recharge, which is pretty much going to be explaining why they can't recharge. So overdrawing, I'm going to be talking a little bit about La Paz County, which is the county that we talked about because it is a pretty good example and it is a kind of a future glimpse into what's going to happen if we don't make some changes. So obviously wells are drying up, and they're not really drying up, it's more of that they just don't reach deep enough. Um, so because they're areas that have more money, or not areas that have more fun, but farming corporations that have more money can drill wells deeper, they're able to actually get closer to the water, or not closer to the water, will get deeper, and so when they keep on taking in water, then the other areas that are usually like community areas or whatever, their wells are generally not as low, so they lose water faster, or they are the ones who don't get the can't reach the water supplies. So also, of course, this also brings up risk of contaminating the water supply because these deeper wells. This is a just an example I found online. So the these clay barriers, they actually protect the water that's underneath, and they make it so that way this water is going to be very good and very fresh, but this clay would protect it. And then when you break the clay, obviously contaminants can get inside, especially when you're digging. So when you drill a deeper well, the water underneath can be contaminated a lot easier. And then a lot of the water is going to crops and cattle rather than to individuals, which makes sense. We need to be fed, obviously. But because a lot of cattle and crops are being fed, runoff such as manure gets into the surface streams, and ones that aren't protected by these big clay barriers, aquifers, they can be infected, they can be contaminated through these streams. So that and runoff from like barnyards, from nitrogen-based fertilizer, things like that, they can all infect these streams, which lead to infecting the aquifers because everything is connected. So overdrawing from wells, I'm going to go a little bit deeper into it as well. So areas like La Paz County in western Arizona, homes are no longer a lot of these counties, they're no longer having access to water supplies because farming giants are pretty much just doing what I talked about earlier, where they're having deeper wells, so therefore they can get the water, and then when the water level lowers, the farming giants aren't getting hit while the communities are, and then the water is being shipped out in the form of alfalfa. A article by Rob Odell and Ian James points to Aldahara, a agriculture company in Arizona that has affected Western Arizona homes, where they are growing alfalfa, like we talked about in that one assignment, where they are making alfalfa and then shipping it to the Middle East for their crop for their cows and cattle. This is leading to a dropping or draining of the aquifer. Um, from the same article, they monitored the water supply using satellites in 1991, and they've been monitoring it for a couple years, or for obviously since 1991. And then in 2018, they checked again, and it's dropped 3 to 4 feet since then. And they've also calculated that there's going to be that yearly it's about a 2 to 4 inch drop, every year, and that's what it is right now, or at least as of 2018. So So a lot of articles are actually pointing to alfalfa and hay as being produced to feed cattle as a major source of water, being or of water drainage. And one of the articles also cited, I believe it was the Mark and Odell, cited that 1/3 of the water is used is going to cattle alone. Another article by Mark Zastro that has been monitoring Lake Mead has shown that there has been a steady decline in Lake Mead's water supply above ground, so the surface water supply, but underneath the ground in the aquifers, they're actually draining much faster than Lake Mead is above ground. He also points to agriculture as a reason for shrinking. And so it's kind of everyone knows the culprit, but also like there's nothing you can really do about it because obviously we need food. So fertilizers that have a lot of nitrogen, when they're used to make the crops healthy, obviously, but because the crops can only take up so much nitrogen, it runs off and it's not used. And that's why it goes and sinks into surface water like rivers and streams and lakes and all that, which seeps into aquifers. The nitrogen can also create algae, which pretty much makes anything in there that needs oxygen to die, and they die of hypoxia. Most things in the water won't survive except for not even microorganisms usually survive. Uh, Also cattle manure, they also produce a lot of nitrogen because there's a little bit of nitrogen in their excrement, and it also is another problem that leads to runoff. It's mainly a problem in areas that are cattle areas. A lot of farmers are also not really looking for any kind of regulation on this because obviously it makes it harder for them to do what they're doing, but also it's for the future of the areas. So areas that are going to be affected the worst, or at least by this in the Midwest, are of course going to be Arizona and New Mexico, and then Southern California and Nevada. It's going to mainly be these three that are going to be affected the most because they have a lot more of the farming industry or not of agriculture in them. New Mexico has always been draining, and Arizona, we have of course the alfalfa production and also a lot of cattle. And also in Southern California, they have their crops, they have their citrus and all that. That is going to be taking a really major hit if the changes are made. So the reason why these areas are the most at risk is because according to the Environmental Encyclopedia, arid regions like Arizona or California or Nevada, they are not humid, so they are very arid, which means that the water that is underneath the ground, it's called fossil water. And the reason why it's called fossil water is because it's like gas. It's been there for thousands of years because it's been building up for thousands of years. But now that we're tapping into it, it can't really recharge because the area is too arid. It's not gonna rain. It's not gonna really recharge from it. Or also a lot of our soils too solid for the water to really sink in effectively. It usually just evaporates really quickly. Whereas other areas in the southeast, they're very humid, so they don't have the same issues that we are having because the water can actually recharge, or the aquifers can recharge. So this is a problem because if this area it loses aquifers, this doesn't just affect Nevada and Arizona and New Mexico. It actually affects everyone because the world's water table lowers a little bit from everything, because obviously everything is connected. So if problems happen here, then problems are eventually going to be happening in other places. So other areas that are kind of following the same trend is going to be areas like China, and specifically in the northeast or in the northern plains of China. Their water table has been cited to be falling 5 feet a year, which is massive. But also you have to look at the fact that China has a much larger population than just a little corner of Arizona, the southeast of or the southwest of America. So the reason why they're having a lot more problems is because they have to feed more people, and their water table is going to have to support those people, or they're going to be hungry. So there are solutions, of course. So ways that you can help is so a lot of ways. So an article by Zach Gudo says that aquifers will recharge eventually with the absence of humans. So basically, what he proposed was we cycle the land, or we cycle the aquifers. It would be pretty difficult because obviously aquifers are underground, so it's hard to, you don't really see the borders, and also farms aren't going to be able to really move. But cycling the land would allow the greater chance for the aquifers to recharge. Uh, then also a similar point is allowing land to remain farmland to remain fallow, which just means unsown, and letting it have seasons to recharge. Because in Arizona, we are an area where you can farm year round, so it's a lot harder to leave, or it's a lot less profitable to leave land for a season. So that land gets used pretty quickly, and it's being used faster than water can really allow. But another good thing about this is that for areas with cattle, you can actually let the land, if you were to let the grass just grow and then allow weeds to grow, then you can actually feed them with those weeds in that grass, and you don't have to worry about the soil being damaged. And also, it actually takes up a little bit less water than alfalfa, that is. So, more solutions that can be done is done by study that had this finding that methodology revealed internal motivations play a much stronger role in driving these organizations to participate than do external motivators. This was a study done by Roberts, Jones, Quatel, and Duke. Um, Basically, what the study found was that even if there are incentives like money incentives or other incentives that are external, they're less likely to affect the opinion, or at least affect the choices if the corporation or the people supporting it don't really have the internal motivation. So if they don't really care about this, then they're not going to put it. Even if there is a lot of incentives, they're not going to care about it as much as if they, unless they care about it personally. So they found that a good way to actually create support for these water cycles and all that is through education and knowledge. A lot of people are calling for a tax that is based off their water use. This was also done by Odell and James. A lot of people are very upset about this and they don't really want it to happen, but it is something that is being thought about. So what you can do as a person is you can lower your own personal water use, like water-friendly supplies, stuff like that. You can talk. Another big thing is talking to people about water issues. So actually spreading the word and like talking about it and being very open about it. You can volunteer at places like Agritopia, which are places where they install like water drip systems for agriculture, so that way they can use less water. And you can also educate yourself, which is of course, you're just going out of your way and finding things for yourself so that way you can further your education on it. And then when you talk about it, you can actually be educated on it and actually know what you're talking about. So, things that we might be facing if we don't change is lower property value because if there's no water there, then no one's going to buy a home. Loss of jobs because obviously we're going to be losing farmers and people in that area. And we won't have the easy access to water that we're used to, which these two are connected for that. And this is my works cited. I hope you all have a good day and goodbye.